All right, question 2, I think is quite confusing to many of you because of the printing errors of the position of the eyes and the size of the eye given. Yes, by right, you should be drawing the light ray to go into the eyes, okay? But in this case, because there's an error there, we have no choice but to redraw the position of the eye, okay? So what we have done is to mark out the position of the apparent depth first, okay, and that the image has to be directly above the object. Then when you draw the light rays, okay, they must meet your incident rays at the water and air interface. Okay, so they have to meet at this interface. Then you continue your light rays straight out to where the eye is supposed to be. Okay, so it's unfortunate that the eyes have been printed wrongly at the wrong position or with the wrong size, and that causes the confusion. Second question asked is, can you estimate the position of your image if you do not have any sufficient information to calculate the apparent depth? Yeah, if you do not have the necessary information, you just have to do an estimation and locate the position above the object, okay? But later on in IP3, when you have learned about the angle of incidence and angle of refraction, you can actually measure them as well and to draw your accurate ray diagram as well if you are not able to calculate the real depth and apparent depth. So usually you will have to draw to scale, or those questions that require you to just complete the ray diagrams. Okay, the next question you have was about question 2, asking whether the light ray should enter the corner of the eye. Yes, by right it should. So a bigger eye should have been given to you in this particular example here. Okay, but here we are focusing on the concept that your light rays are drawn such that they refract from the glass block to water, okay, optically denser medium to less dense medium, they bend away from the normal here, okay, and then when it comes from water to air, again it is optically denser medium to less dense medium, the light ray is going to bend away from the normals again. All right, so by right your eye should be at this position, so big here, right? Then we also want to learn that the light rays, when you trace back in straight lines, this is where the image position is, and it is directly above the object. Okay, so same problem as question 1, the position of the eye, the size of the eye that is confusing you. Okay, the other question, question 3, that many of you are asking how to do this. Okay, so then they're asking how the normal is drawn at certain angles. How do you know what angle to draw? Okay, so we'll do this question together. Okay, so the incident rays are entering the glass block. Okay, so this is the glass surface. The incident rays are actually perpendicular to the glass block surface. So this is actually where the normal is at this interface. So here the angle of incidence is actually 0 degrees. Okay, so there's no bending of light. The light ray just enters the glass block straight. Okay, but when it comes from the glass going into the air, then they were going to bend towards the bend away from the normal. Okay, so where is the normal? So at this particular point, because this is a curved surface, so we need to draw a line that touches the curved surface at one point only. Okay, so it touches it at this point. We call this the tangent to the curve. Then our normal will be perpendicular to this tangent line. So I have my normal drawn in this way. Okay, so this is my normal. And we know that from glass to air, the light ray is going to bend away from the normal. So by right, if there is no bending, the light ray is going to come out this way. So now we want it to bend away from the normal. So we go this way, this direction, far away from the normal. Okay, same thing here. This is the tangent to the curve, so it touches only this point, and the normal is perpendicular to the tangent. So since the normal and the incident ray is lying on the same line, angle of incidence here is 0 degrees again. So this ray is coming straight out without any bending. Okay, then you draw a similar thing here, and that's how you get your points to converge at one point, your rays to converge at this point, and then you found your image position. Okay, another question asked was, what's the difference between convex and concave, then converging lens and diverging lens? Okay, so a convex lens is actually thicker at the middle, so it's referring to the shape. The concave lens is thinner at the middle, so this is referring to the shape. Then the converging lens, okay, is because when the light ray passes through, okay, they converge the light rays. So the function is to converge the rays at a point, so it's called converging lens. And then for your concave lens, okay, when the light ray passes through, the light rays are actually diverging out, so it's also called the diverging lens. Okay, so the terms are actually used, convex and concave is used to refer to the shape of the lens. Converging lens and diverging lens is used to describe the function of the lens, but they can actually be used interchangeably. Okay, one more general question that was asked is, must the angle of refraction for like both the refracted rays be the same? Answer is no, because later on when you learn the formula to calculate, you know, you're using actually sine I over sine R. This sine function is not a linear function. So first, they are not incident at the same angles. Two, because of this sine I over sine R, the refracted ray will also be at different angles from each other. So they are not the same angle of refraction for both rays. Okay, next question is, do you always have to draw the normal when you're drawing ray diagrams? Well, it depends on the question that you're doing. Like these kind of questions where you need to show the light rays bending away from normal or towards the normal, then of course the normal has to be shown. Okay, whereas for this kind of examples, okay, where the concept is to join the image position, the rays to intersect at the interface, then it is not necessary to have the normal, but you can always add in the normal to do your check, okay, to show that your refracted rays are bending away from the normal correctly. Okay, so it depends on the questions what you have. Okay, and the other thing is, please remember to check that for all your light rays, you have the arrows drawn in to indicate the direction of your light correctly.